today, but we've really got to focus on the future. So our priorities, number one priority is just having a warfighter focus in everything we do. Every decision we make, if it is not in line with increasing capability to the warfighter, then we're not focusing on the right thing. So that really is really key to us. Our main mission is to deliver the war-winning capabilities that our warfighter needs today and tomorrow. That tomorrow is an important part that drives our decisions as well. Second priority, increasing our acquisition tempo, our ACT tempo through speed and agility. Number one priority is really about what we deliver and what we do. Number two is how we do it. We have got to look at new ways to do business to increase speed and agility. How quickly can we get those war-winning capabilities to the field and pivot and respond to emerging threats faster and quicker than the standard 8 to 10 to 12 to 14 year acquisition cycles that we have all come to know and love. And last one is taking care of our family is a big priority for the Directorate. Both facilities and standard of work and the work environment, but also in developing them to get the most out of them, the full potential of our workforce, of our family. That involves training them on what digital acquisition is, what Agile is, what the lines of, what authorities they have to get after speed and agility, how to calculate and take risk. That's an important thing that maybe a lot of us in this acquisition world haven't been taught growing up. So that's a big part of it. So those are the priorities that focus everything we do every single day. But then we've also set up strategic lines of effort, efforts that don't tie just to a single program or a single capability, or even to today or tomorrow, but they're big picture, long-term thoughts on what we need to do and how do we need to get after those priorities. And I did talk about those in the fall as well, that many will remember. One is digital acquisition and sustainment. A big, broad topic. Many will probably think of Dr. Roper's papers on the digital trinity and all. Those are all true. Those are all part of this. It is how do we bring the 21st century tools, infrastructure, capabilities that are at our fingertips, they're not in development. They're today being utilized by a ton of the commercial industry. How do we bring those into the work we do in defense acquisition and systems acquisition? How do we bring that tool set? How do we integrate the data sets together to have better data-driven analytics to support our decision-making? Second is agile weapons enterprise. How do we get to an agile weapons enterprise? How do we instill open systems into the designs of our weapon systems, but also into our portfolio management strategies, our acquisition strategies, our business strategies, and contracting strategies? We have a tendency, our history is you do a source selection, you pick a prime, and then that prime has full control over that product line for the rest of its life. No, that is not how, that's not, I think, getting after the true speed and agility that we require. So Agile Weapons Enterprise and Ben Collins, who will be talking tomorrow morning, will go a little bit through some of our initial tranches and thoughts to go there. But that's an important one. And third is improving the family's quality of life, is the workplace, the environment, the inclusion, the diversity, but also the professional development capabilities of that. How do we again get to the full potential of all of our workforce? So in summary, I'd say our nation is at a critical time. It's at a critical inflection point, and there's great needs and great expectations for our service, for the Air Force, but also for this weapons enterprise. As I mentioned, we have a plan, we have a vision of where we want to go, but we don't have all the answers. We don't exactly know how to get there. If, frankly, we'll never get. This will be a continual journey and a continual journey of improvement. We need to be an agile enterprise, just like we want our weapon systems to be agile in design. And that's where forums like this and people like you, why we have these engagements with you, is this enterprise accomplishes great things together, not individually, not single-handedly. It gets there. We will get there based on the inputs of all of you, the insights that you all have, and how we bring those together along this common theme. But we are going to need your commitment. We're going to need your candor, your openness, your transparency, your ideas in the right forums. And at the right time. We also need your ideas. We are not the central hub of great ideas. Some of us, may actually say we're the antithesis of the place for great ideas, but we are looking for the great ideas to integrate and how we do that. And frankly, we need to look past the system that we've all grown up in. We've grown up, we've been institutionalized in a process, in a thought pattern that abhors risk taking, that averts it at all possibilities, that basically looks to minimize risk by not changing fast enough and by putting so many requirements and so many questions into the system that we cannot. It seems the exception. The rapid acquisition organizations are the exceptions. The ability to move fast seems to be an exception in today's world. And that's not because of the authorities in the process. That's because of the mental models and the people and the trust patterns that we have instituted in this acquisition business. We've got to all break that to really get after what we should be looking like in the future. I'll close with referencing a book that I recently read called Kill Chain by Chris Brose. And in it, Chris really focuses on how the military warfighting kill chain of today was based on the Soviet model. It was the kill chain that was really perfected to go against the Soviets in Europe, and how that has been the kill chain we've utilized through Desert Storm, Desert Shield, Afghanistan. Up till today, we're still in the mindset of that old kill chain. And he posits that we really need to break that mindset and get to a kill mesh, or a much more dynamic kill chain, utilizing the technologies and the capabilities of today. So first off, clearly that thought, I think, really syncs with our joint all-domain command and control warfighting concepts that are coming out of the building, and also the Air Force's Advanced Battle Management System, ABMS, construct that's going forward. And what that's going to mean, it's clearly going to drive new capabilities, new areas to improve how we use weapons and how weapons fit into this overarching kill mesh and this overarching sensor to shooter timeline system. But I'll also tell you, I'd extend that concept of a new kill chain to acquisition, to our acquisition kill chain. And really that was at the heart of what we did the pivot for, was to get after this acquisition kill chain. How quickly can we go from idea, concept, to sensor, to a no-kidding capability in the hands of a warfighter delivering results, the actual end of that kill chain, and how do we better increase the speed and agility of that acquisition kill chain? And it's across the entire life cycle, from S&T and lab work, industry R&D, through the development, actual program development, through test, through ops, through sustainment, and back around in a very agile cycle to get new capabilities out there. We have to increase our, and that's really at the heart of the pivot. Digital, agile, open really gets about increasing our ability to rapidly connect, reconnect, and think of new ways to connect our sensors and our shooters, our labs, our users, our industry partners, our developers with our SPOs, our testers, and everything in the like to get that. We need to increase the speed to first delivery, but through agility, we need to increase the speed to all subsequent deliveries. We need to increase our ability to on-ramp into, out of, and across our portfolio. And that is a true shortcoming, I believe, in the portfolio that I see today. We are not leveraging capabilities quick enough between programs. Every program starts and they've got this huge vertically integrated set of development they need to do, and there's not as much plug and play between the silos within weapons, but even outside of and coming into weapons. And then through that digital and that open and agile backbone, increasing our options in our trade space, increasing our access to the data, to the analytics, applying AI and ML to help us with data-driven decision-making, and all of it focused on putting those award-winning capabilities into our warfighters' hands. Gone are the days when we develop a weapon system, a weapon in this case, and expect 10, 15, 20, even 30 years down the road for us to have the exact same weapon upgraded along the way. I'll give you that. But we have the portfolio today almost identical to the portfolio in name that I had, that was in place when I came in as lieutenant 27 years ago. That is not the case. The lieutenant today, 27 years from now, we should have an environment that gets them a completely different set of capabilities. So thanks for your time today. I really look forward to the feedback. in the future engagements on how to make this real and how to move forward. I'll try to drop in as my schedule allows, but really the back brief, the out brief after this is going to be really great. So that being said, I like to use the term, we all got to raise our game. We've all got to raise our game, and I look forward, we're going to raise it together because we need to do that to raise the entire enterprise. And then lastly, it's on my wall. We need to go fast. We need to think big. We need to not get mired into the near-term win mindset that we so easily fall back into. We really need to think the long term in the infinite game. Look forward to working with you and talk with you in the future. All right, let's get after it. That's it for me. Thank you.
Thank you, sir. We appreciate you being on this morning and for opening the event today. So next up, we have Brigadier General Scott Cain, Commander of the 96th Test Wing here at Eglin.
Well, thanks, Laura. Good morning, everybody. Thanks, Heath, for getting us started today. I think I'm going to spend most of my time talking about Open Agile Digital and what the test wing is doing. But I do, after hearing Heath's comments, want to let everybody know that the 96 Test Wing is also focused on and looking at plans for how to best support our future requirements, and the enterprise, the weapons enterprise is central to that. And we're looking at what we do as a wing as far as our competencies, what we do to support this test range that you use so that we can prosecute testing in long-range kill chains, JADC2, and our platform avionics. And to do that, it does take a different kind of thinking. It takes a different kind of range, and it takes a different kind of competencies out of our people. So I think General Collins has it spot on about where we need to focus. But I do want to shift kind of back to Open Agile Digital, and I'll look at some places that you might not expect, because as we're making this transformation, some of those skill sets and that competency building is happening in different pockets. But ultimately, we're going to bring it to bear on our entire capability as a test wing, and that's where the Air Force Test Center, frankly, is going as well. So to start, I think I'll mention Weapon 1, and I imagine Colonel Haase, who's going to follow me here, is going to talk about this a little bit more, so I won't steal too much of his thunder. But on the Weapon 1 effort, the test wing is really where we're focusing, and I guess I can open it up a little more than Weapon 1. I get a lot of questions now of what does test mean in digital acquisition and digital engineering environment, and we're really focused on the validation and verification of the digital twin ultimately, and we're going to be doing this with hardware in the loop in labs. We're going to be doing this in open air testing. For Golden Horde is a great example of that, where we're taking flight test data right now that informs those models. So as we build towards test that supports the digital enterprise, we're working closely with AFRL on integrating capabilities into our ground test infrastructure, particularly into the GWEF, the Guided Weapons Evaluation Facility, for Gray Wolf, and possibly some other options of weapon programs that will integrate there as well. While we're doing this is building skill sets in model-based systems engineering, getting our program management versed in Agile, and identifying where our limfacts are. We definitely have limitations in our connectivity, both just in the processes that connect the organizations that are involved in this, and the lab, the acquisition, and the testers. But also just the IT infrastructure, our non-core networks that we're needing to build. We have more tools that we need to bring to bear. So we've got some good momentum, but we've got a lot of work to do. And I think Colonel Haase will probably talk about this a little bit more. But this is kind of one of our focuses for how we build the skill sets for supporting the digital enterprise from the test perspective. I will say one of those things is I've mentioned this before in a couple of forums that we're working hard with our base comm, and with our cyber test group actually on building up that transport backbone to build what we're calling the bandwidth superhighway. But that is the optical transport network project that we're trying to install that can get us up to the right speeds for moving data around. I want to talk about, I mentioned a couple of maybe areas that you wouldn't expect where we'd be building competencies for digital. One of them is our range. So we have a Gulf range enhancement program that's been going on for several years now as we build out the range to have capability across the expanse of the Gulf range for data collection, for supporting long-range kill chains in particular. We're using a model-based systems engineering environment to define the requirements for one of our sites that we're building up down on the Gulf Coast. So as we enhance and expand that capability, we're building a range model at the same time, and we've built the requirements definition for that site in particular off from a model-based approach. What we would like to do is continue down this path for all of our range modernization efforts, but also we think that this is going to be a good way to a good capability for supporting our test customers, so that you can look at our range model and know exactly what it is that you need to satisfy your test requirements, where you can make trade-offs. So a little bit of a maybe not expected area where we're building our digital chops, but it also is going to be a test capability that you can use as well. So we're kind of excited about that one. Last but not least, I think most of our competency in Agile is out of my cyber test group. And I think where this is going to come to bear is as we continue to build multi-domain test environments, such as the Emerald Flag exercise, we have a convergence, so to speak, of our cyber test group, of our operations group, our range group, and all the work that they do together. And so my cyber test group teams have been deep into Agile for quite a while now. The 45th Test Squadron and the 47th Cyber Test Squadron in particular are working with organizations like Kessel Run for AOC software, Kobayashi Maru for space operations software development. The 47th Cyber Test Squadron works with Level Up and others. And we've built up a decent understanding of how test integrates into the software factories, how it best complements and works with the Agile process. And I think these competencies in the test wing are going to be the ones that come to bear on the broader weapons enterprise as we move forward in the future. But that's really where it's growing and where it was born, at least in the test wing. Now it's a matter of bringing that to bear more widely. I'd like to kind of just finish with just a couple thoughts on that role of test in the digital enterprise. Really, I think that I mentioned the model validation piece up front, but I would summarize it as we're building trust in the model, because that's where we are in this journey, but we're going to need to do that with each program. We're also just building power in the model, and I think that's where our test data will and test knowledge, as we're calling it, will really come to bear here. My tech director would let me hear about it if I didn't mention this as well, but we talk a lot about early tester involvement. And I think as we make this transition, it's going to continue to be vitally important to have the testers involved early from a couple of perspectives. One is that military utility, which from a developmental tester, that might sound like a little bit out of my lane, but from a big T test perspective, as we integrate DT and OT just as a matter of practice now, it's going to be important to have that warfighter perspective, both from our developmental and our operational testers from the get-go. And also the test enterprise, I think, brings a process discipline that's going to be important and valuable to you in the acquisition community as well. So I'll wrap it up there and save a couple minutes for Garry. But I want to thank EB and our industry partners for participating today. I'm excited about this platform and being able to participate in this future, and wish everybody a good rest of your day. Back to you, Laura.
Thank you, General Cain. And next up, we have Colonel Garry Haase, the Commander and Director of the Air Force Research Lab Munitions Directorate.
Thank you, Laura. Thank you, General Collins, General Cain. and especially all of you, thank you for joining us today, tomorrow for this Armament Industry Roundtable. We've talked a lot of partnering here from the weapons enterprise with AFRL on the S&T side to the 96 with developmental test and PEO weapons for the ultimate acquisition and sustainment and getting those capabilities into the hands of the warfighter. And we need that other piece, that partnership from you, industry, is that aspect to help us take some of these ideas and technology into that, turning that into that capability into scale for our forces. So excited about that partnership. We'll be talking about other ways over the next couple of days that you can partner with us, as well as areas that are of particular interest. So a lot of discussion about digital here, and that's how we see being able to go fast and scale up and be able to more rapidly take those great ideas that are out there with you and industry and other places that we can continue to develop those concepts, mature those technologies. As we talked about WOSA, Weapons Open System Architecture, our government reference architectures and modularity, how can we more rapidly insert those great technological capabilities to continue to keep us on ahead of the curve from our adversaries with technological capabilities and more rapidly insert those. So excited about all the different topics that you're going to hear about from the government side. We're very interested, as I said, partnering through numerous different ways and expanding our ability to, as General Collins was saying, get ahead of modernizing our weapons that we need either to hopefully deter our adversaries from a potential conflict, or if a conflict turns hot, to stay ahead of them and keep the fight unfair in our advantage. So excited with AFMC. You may be aware with the digital campaign underway. We're excited as part of the weapons enterprise. General Cain mentioned, and you'll hear more about Weapon One, especially this demo that we have done over this last year of pulling together the whole digital thread, looking at that whole concept through taking advantage of the digital twins we have to be able to do different concepts in that virtual environment, find ways and use the digital tools, find ways to improve on that. And lead towards greater capability within the fight. And so we are, as an enterprise, but not just as an enterprise, we as a weapons enterprise are a pathfinder as part of the AFMC digital transformation campaign. Excited about that. So it is as I'm sure you're well aware, a big push across the entire department, but I'm proud to stand with General Collins and General Cain as leaders forefront into making a reality of getting that capability in there through use of this digital transformation that we're going towards. So you get a lot more details in a number of upcoming briefs here, and I just appreciate the great partnership across the weapons enterprise. It's not just the government side, but especially industry and what you can bring to bear with your good ideas through IRAD, through cooperative research and development activities with us in the government or direct contract capabilities. So thank you, enjoy, and take notes, ask questions when able, or certainly follow up with us to see how we can best partner to get after this fight as fast as we can. Thank you.
Thank you so much, Colonel Haase. Up next, we have Weapons Digital Enterprise with Dr. Craig Ewing from the Air Force Research Lab, Munitions Directorate, and Lieutenant Colonel David Hoffman, AKA Haase, who is fully embracing Mustache March. He is from AFLCMC Armament Directorate.
Good morning, everyone. Thank you, Laura, for noticing the mustache as well. Certainly March, that's for sure. I wanted to take this opportunity to talk through a few important kind of scene setters for today. First, Dave Hoffman, as Laura mentioned, I go by Haase. I'm dual-hatted within the Air Force right now. I have a hat as the Disruptive Futures Branch Deputy, Disruptive Futures Division Deputy, and also the Chief of the Digital Acquisition and Sustainment Office, which General Collins alluded to earlier, is part of one of the foundational underpinnings of his digital pivot within the portfolio. But even more relevant to today's topic, I am one of the three hosts for today's content. Myself, Dr. Ewing, and then Colonel Creviston this afternoon bring the three parts of the government part of the weapons digital enterprise, or the weapons enterprise. Certainly industry is a key part of that, and it's why I stand before you and the remainder of the topic presenters, as well as the earlier leaders, to ask for and to seek a partnership and engagement with you all. So I thought I would narrate kind of big to small. So why digital transformation? We know that the commercial sector has been doing that. We know that the commercial sector outpaces in the past. The government labs were at the very forefront of technology, and now we know that the corporate sector has an edge over some parts of the technology evolution. Your cell phone or desktop computing are good examples of where the government does not have an edge on. But there are other areas where the government still maintains that edge. That transformation took place in the corporate sector, and is now we're trying to incorporate it into the government sector. There are a couple tenets that the leaders touched on earlier and that we've heard before: open, agile, digital. But why those specifically, and how do those meet our need to transform? Well, to me, it's really about the nation's ability to compete with the other competitors out there. Some may call them near peers. That competition is not just military; it's also diplomatic, information, and economics. And that economic part, along with that military, there's tremendous synergy there. And so our ability to create open, agile, digital ecosystem allows the commercial sector as well as the military portion to grow together. That rising tide raises all boats, if you will. But we know that we're engaged in competition. We have shifted from low intensity conflict back to a focus on competition that could include major combat operations against a near peer or with a near peer. So how do we prepare for that? Well, we prepare for that as Chief of Staff Brown says. We need to accelerate that change or lose. And he used very specific words there, and he's driving a very specific point. Our change is not fast enough. It is not rapid enough. And our acquisitions arm has certainly never been accused of being overly rapid. And as General Collins had mentioned, that rapid stands out as an exception rather than the norm. And so enablers to that, as previous Senior Acquisition Executive Roper mentioned, are the Trinity: digital, agile, and open. So bringing those tools to bear allows us to do a few things. It allows us to have government-owned solutions and then to scale them to the enterprise level, at least at the weapons enterprise level. It allows us to have a reference architecture so we understand how all the disparate pieces connect together. And it also allows for, through the use of weapons open systems architecture, those interrelated parts inside of weapons to connect together. We look for models-based systems engineering to enable our engineering capabilities. Certainly that's been a capability for a long time, but doing that in a full digital environment will be new to us. We know that our IT is one of our limiting factors, and we know that gaining control of our tech stack and how we treat our authoritative sources of truth is very important. But the unwritten one there that's most important is collaboration. And that collaboration is what I hope that you see demonstrated today. This event is hosted by all three of the government entities here on here at Eglin. The test lab, the test wing, the research lab, and also the Armament Directorate. All three of us working together along with the corporate sector to build an enterprise level approach to getting after this challenging problem, to ensure that the nation is competitive when it needs to be, and if called upon, is able to defeat or deter enemies at our choosing. So with that, I'd like to introduce one of the co-hosts of today's content, Dr. Ewing, and he will talk quickly about, he will talk about how the enterprise is laid out, and then we will circle back for a few minutes to talk about some of the recent developments, and then we'll start into some of those how that were detailed. And you'll hear this theme over and over again, because these are really our how we see this whole endeavor proceeding. So Dr. Ewing. Yes, sir.
Thanks, Haase. If we could go to the next chart. Good morning. I'm glad everybody could join today. I'm just going to give you a very big, broad brush overview. As the Weapons Modeling and Simulation Senior Scientist for AFRL, what we're doing here in the Air Force with our digital weapon digital enterprise is also now being, besides weapons only, it's also being transitioned out to a lot of the other areas across the Air Force. And as it was mentioned earlier, it is part of the AFMC digital campaign as well. So I'm just going to try to give you, if you looked at what we're doing in one chart, this is the chart. So you notice that at the very top of that chart, it says Weapons Enterprise. So this has started actually only 16 months ago, which is kind of hard to believe. But in December of 2019, we had our very first meeting here at Eglin amongst all of the different organizations that are involved with weapons acquisition, and started talking about what does digital enterprise look like, what is digital engineering, how is open, agile, and digital going to work for the weapons enterprise. That was an initial meeting that had about 115 different people here. We brought in representatives from the Digital Engineering Office in the Air Force, from AFMC, from the Navy, all trying to get an understanding of what is this going to look like for the weapons enterprise. And we then started down the development road, and it's an amazing, in my mind, an amazing feature, in fact, that we were able to actually start transitioning products across the enterprise in just that short period of time, since 16 months. But if you're looking at this chart, starting, and notice that at the very bottom of it, I know it could be hard to see if you're looking on a tablet or a small laptop, but behind that weapon that's streaming all the ones and zeros across it, the intent there is to say this goes from across the acquisition life cycle. It's not just a laboratory or a SPO or a test wing or a sustainment operation. It is a unified operation across the enterprise. So if you start all the way at the left-hand side and you're looking at, we are incorporating the Air Force futures and the warfighters' needs, requirements, and documents into a model-based systems engineering capable SysML program. So we're using at the current time Cameo, but all of those Air Force mission threads and requirements and all of the existing systems have all been architected out now for several different mission areas for the Air Force. And we are integrating those capabilities from model-based systems engineering with our modeling, simulation, and analysis tech stack. So this is our tech stack. If you can read it on that chart, it happens to be called RogueONE. That's what the big R1 stands for there. But it is a conglomeration of commonly used tools for the Air Force integrated in with our model-based systems engineering. And we are working towards creating continuous improvement, continuous delivery of our software capabilities, as well as a continuous authority to operate. That has always been an issue for the Air Force, and it's something that we are trying to overcome with the digital engineering effort that we're working on right now, is always having access to the right tools that you need to do the job. With that model-based systems engineering and the software tech stack, we are actually now starting to work on incorporating other people's MBSE models, for instance, from the space community, from ABMS communities, from platform communities, trying to integrate our weapons environment with those other digital engineering environments as well. And you can see on the chart there, it talks about ABMS and JADC2. In February, Weapon 1 actually played as a player in ABMS on-ramp 4. So we were able to demonstrate how weapons would communicate with that structure. And you'll see later on today an actual environment that we demonstrated the digital engineering kind of life cycle for a 24-hour ATO update for weapons. We also think that that's valid to be seeing those happen in flight as well, to do software updates of those. So we're working with those structures for ABMS and JADC2 to look at how do you do computing at the edge? How do you transfer that data from the edge back to a digital twin model, and then use AIML techniques to look for upgrades to those weapon systems, and how could you then improve them and basically come out with a new looking offense every day. So it's not it doesn't look like the same weapon we've seen for 27 years and the same tactics that we used. How do you update that on the fly and come out with an adaptive structure that confuses the enemy? So we're working, it was stated earlier how we're working with our digital twin models, integrating them into our ground test facilities, also integrating it with flight test as well. How do you validate and accredit those digital twin models for use throughout the life cycle? You can see the products listed on this chart. So we're working on digital ecosystem for the weapons enterprise here. How do you be able to transfer data around all the way from the lab to the SPOS to the test wing and through using the PLM software through the life of the program? How do you get access to that data? How do you find that data? Where is it stored? Multiple federated authoritative sources of truth. And then the digital twins integrated with our testing situations. Also putting out a government reference architecture for how you would integrate your systems into the government reference architecture for weapons. And there will be many versions of a GRA, but we are developing at least a suite of them that all fall under the same general heading. And all those pieces and products are used by the entire user community for weapons digital enterprise, all the way from R&D to testing to project management and eventually into sustainment and operations and training as well. So I'll stop there because you're going to see a lot of different briefings throughout the day today about all these different pieces and columns that go across this. And you'll get a little bit better idea what the work that's been going on in those areas are. So I'll let Haase come back and wrap up with some comments, and then we'll get on to the different briefers throughout the day. Thank you very much.
Thanks, sir. Appreciate that. Wanted to touch on, as I mentioned, now we've deconstructed what the ecosystem would look like. want to talk a little bit about some of the developments within the enterprise to date. This is certainly not all-inclusive, just a few teasers, if you will, that I think are germane to the conversation over the next 2 days. And then after that, we'll start to drill down into those kind of lines of effort, if you will, with a discussion on the government reference architecture. So major developments for of recent is digital acquisition across the entire life cycle of weapons. So you saw the senior leaders this morning from all three government entities. We talked with General Cain about testing and about integration of emerald flag, orange flag, black flag into the large flag exercises, and how digital is a big part of that, as well as other live virtual constructive testing that's taking place, a change in the way the ranges are physically infrastructured or architected. And then in previous forum, we have talked about data analytics and how the 47th Cyber Group, or Cyber Squadron, has done a lot of work on taking all that mountain of data and turning it into knowledge. As General Cain said, it's really about knowledge management. In AFRL, we know they have many programs ongoing right now and are the thought leaders in a lot of areas. One specifically you heard just a few moments ago is WOSA, and that was the initial architecture of the enterprise ecosystem, and that we're leveraging that to create that full enterprise ecosystem. And there's also a discussion about best of breed, and we'll talk a little bit about, we use the Golden Horde Coliseum here in a minute or two as an example of that. And then of course, within PEO weapons, General Collins has previously discussed the pivot, but I just wanted to touch on that a little bit more from the Digital Acquisition and Sustainment Office was stood up, and that is the Directorate's first attempt to go after open agile digital with full-time employees. It's a focus. There are a number on the team with me, and we are looking to equip the workforce, not only in the Directorate, but on the base with the skills, knowledge, and training necessary to and tools to get after open, agile, and digital, and bring those effects to the warfighter at a much more relevant timeline. So that entire weapons life cycle. We also have, as an example, the Golden Horde, the Coliseum, which is an Air Force Vanguard program, which means that it's given increased scrutiny and also increased emphasis for success. And while one part of it is the collaborative and autonomy portions of having two or more weapons networked together, it is really more about how do we demonstrate, or how do we build a digital coliseum, something that technologies can go into the digital environment and demonstrate their capability, and from that, the government is able to identify best of breed and pull that into ongoing development as well as sustainment activities. Certainly, there's a lot of change. When you say pivot or transformation, you are messaging significant change. And so with that change will come a lot of knowledge management discussions, a lot of forum to share our perspective and fight for feedback from all our participants. And it also requires within the government a lot of training, and I assume as our partnerships grow, that will be shared back and forth. But how do we bring a lot of very seasoned experts on acquisition, but very novice on digital acquisition, up to a level of knowledge necessary to prosecute at the level that's the nation requires to deter or defeat? So those are things we're thinking about. We certainly want engagement from you all. We're fighting for feedback on that. We have time set aside tomorrow, and then we're opening up multiple new avenues of communication for that. This event is just an example of that. We are attempting to do an event like this every 6 months. So that's an external for outwardly facing time to share to communicate our expectations and vision, and also to get back information on how we are doing. And ideally, that helps us all grow and develop those skills necessary to compete in this new environment. So with that, I'd like to end the introductory portion of the event, and then we're going to move into the government reference architecture portion, which is a critical foundational topic for how we expect to do this, because gone are the days where we have multiple monolithic or federated systems. They need to be interactive, and that's what the Joint All-Domain Operations, JADC2, or ABMS discussions are really about, is how do we link these things together? And having an architecture that enables that kind of linkage, that enables open, agile, digital is very important. And the government lead for it is going to talk for a minute or two, and Mr. Dustin Ammons. So I will turn the floor over to him. Morning, sir.
Thank you, Colonel Hoffman. As Colonel Hoffman said, I'm talking to you a little bit about the DoD government reference architectures. I'm going to try to answer 3 questions. First, what is a government reference architecture? Second, what are the benefits of a government reference architecture, and why would we want to have a government reference architecture? And then third, kind of what is the status here at Eglin with government reference architectures, and what is our path forward within the Armament Directorate? So what is a government reference architecture? The DoD reference architecture description that was published in June 2010 says that a government reference architecture is a reference architecture is an authoritative source of information about a specific subject area that guides and constrains the instantiation of multiple architectures or solutions. That same definition was used as late as March 2019 within the Air Force Data Services reference architecture. And then if you look at Wikipedia, it says that a reference architecture is a template solution for an architecture of a particular domain. It also says that reference architectures provide common language that's used to discuss implementation with the intent of stressing commonality. If you look also, the Undersecretary of Defense for Research and Engineering produced a mission engineering guide in December of 2020, and says a government reference architecture is the authoritative government source of information to guide and constrain mission architectures and solutions. It integrates the data, information, boundary conditions, and rules that describe the mission capability needed by the warfighter in sufficient detail to allow for transition of technology-based solutions. So what are the themes that we see here? The themes we see are, it's an authoritative source of information. It applies to a particular domain. A government reference architecture would apply to a particular domain. So in our case, that would be air-launched or air-dropped weapons that we develop and test here at Eglin. It also guides and constrains an architecture or a design, and it provides commonality, both commonality of language and commonality of specifications, standards, those kinds of things. So what does that look like? So we've talked about what a government reference architecture is. We've said that it's going to do all these things. It's an authoritative source. It's going to guide and constrain. But what does that look like in the context of digital acquisition, digital engineering, and model-based systems engineering? Within the DASO office, we believe that looks like a framework that conveys structure, relationships, and interfaces within a digital SysML model. So let's break that out a little further. And kind of how we've looked at it is 2 submodels within that model. So the first submodel is requirements, and then the other is an implementation model. So I'm going to refer to them just as models, but the requirements model would contain a common requirement structure. So that it makes sense that if you're going to develop an architecture and purpose of a government reference architecture is to guide and constrain a given architecture or design that exists for the sole purpose of meeting a set of requirements, then you'd obviously want to capture those requirements in the same model with the architecture that you're establishing as a government reference architecture. So Weapon 1 has done a great job with their government reference architecture. They've identified a number of requirements We've been looking at those, and we think there's an opportunity to leverage a lot of those requirements and establish those 90% of common requirements to nearly every weapon program here at Eglin, and capture those in a generic format where we can capture the requirement in a concise shall statement, leaving the numeric values blank. Obviously, those are going to change from program to program, but if we can capture that, then we'll have that common requirement structure that can move from program to program. Secondly, it's going to include use cases, behavior diagrams, activity diagrams, those things that will give the context of those requirements. It's a lot like the OV1s, or not the OV1, but any of the OV views in DODAF or a CONOPS document. Just gives the context to the requirements. And then, of course, it's going to include the technical architecture. So Jonathan Schaefer is going to be up in a few minutes and talk about the weapon open system architecture. They've done a great job of already identifying the technical elements that make up most weapons. They've identified the standard interfaces, or they've established standard interfaces for each one of those technical functional elements. And so that can kind of be the basis of starting with an architecture. We also have plans over the summer to look into other external interfaces to the weapon and identify those external interfaces and establish those within the government reference architecture. So what we've talked about thus far, we've talked about a common requirement structure. We've talked about use cases, behavior and activity diagrams, and we've talked about standard interfaces, internal and external interfaces, as well as the functional elements that would make up the architecture and that would constrain our industry partners to stay within those common interfaces, which, actually Jonathan and the WOSA team has done a great job working with industry on that. There's an industry consortium, and they've concurred to that approach. So we feel like this is an opportunity to move forward with a lot of commonality here. The other half of the model is the implementation model. And the implementation model, what this does, will provide the contractor with a top-level framework, which they can give back to us. They can fill that framework in with more details as they decompose their requirements and implement their design solutions. So in other words, this is going to guide the contractor to provide a robust model of their implemented design solution. So what does that implementation model look like? Again, this is a framework that's laying out the framework for what we're looking for the contractor to provide back to us. First of all, it's going to be a physical structure. The functional elements I was talking about with WOSA do not dictate a physical structure. So whenever the prime contractor decides how they're going to implement their solution, of course, they would need to define the physical structure. This is what we typically think of as a hardware design. Secondly would be the logical structure. This is typically thought of as a software design. How does all the information pass back and forth between the modules? And that should be very similar to what is defined within the weapon open system architecture, the internal interfaces and the external interfaces that we define. And then the next piece is the really big piece. This is where the prime contractor will create behavior, activity, and parametric diagrams and models, which shows the behavior between the various functional elements. So this is how the contractor verifies that it verifies how the subsystem and modules interact and pass data, power, functional commands, et cetera, between one another to ensure that the mission, or that the weapon accomplishes its mission. So what does this look like? A quick example would be if the contractors come in, they've got a simulation for each one of the functional elements that make up a typical weapon. And some phenomena within a simulation, some phenomena is placed in front of that weapon. We would expect, say, the seeker to detect that. It would detect it, it would send an output. The SysML model would detect that output and then process it appropriately, consistent with how the actual weapon would process it, send it to the next functional element. The next functional element would receive that input, do its processing, provide an output. Again, all these inputs and outputs are consistent with the established common interfaces, standardized interfaces that have been established within the weapon open system architecture or the external interfaces that we'll be working on this summer. So then after detecting that, it sends it all the way through the chain, and maybe the result is it's supposed to move the weapon from its path of flight to 15 degrees to the right. So we'd be able to watch those inputs and outputs go through the series, and ultimately maybe an actuator activates, moves the control surface, and that control surface actually moves, and the result is the weapon goes 15 degrees to the right, just like it's supposed to. So what I'm trying to bring out here is these behavior, parametric, and activity diagrams are not necessarily just data flows. There's a lot of data flow in there, but it can also result in a physical transformation where something happens physically after the data flows go through and all the functionality occurs. So if that's what a government reference architecture is, what are the benefits to having a government reference architecture? Well, we talked about the 90% common requirements within that common requirement structure we talked about the Weapon 1 GRA had provided. So if we can identify those 90% common requirements, and we can write concise statements for those and capture those within the government reference architecture, we can use those again and again. So when the program office goes to create a new weapon program, they can capture those 90% requirements. They don't have to do a lot of work on that. They basically have to go through, find the ones that have the numerical values blanked, put in the appropriate numerical values. But other than that, they've got those requirements established, so they can focus their energy on the other 10% of the requirements, which are the unique requirements for a given program. So they're not spending a lot of time on that. For our industry partners, the advantage is they start to see the same requirements again and again from program to program. They don't have the situation where they saw a requirement on one program, it comes in from a different program, and it's written slightly different. And then they have the question in their mind, is this the same requirement or is it different? Because the requirements will repeat from program to program to program. They'll have that commonality, they'll have a confidence that they've done that before and that they can move out with a solution that they are confident in because they're confident they understand the requirement. We also talked about the internal and external interfaces and bringing those into standardization and commonality. Because those are going to be common across all weapons, now there's going to be a lot more opportunities for reuse. So our industry partners will be able to reuse a lot of the solutions that they've created in the past. And of course, this naturally results in faster times to acquisition. If you can reuse something that's already designed, you just have to drop it in, then that's faster than developing something brand new. The other piece with that standardization is as we develop this implementation model, sorry, my mouth is getting dry. Thank you. Also, with the internal and external interfaces, again, I already said they can do the reuse. With the implementation model that we talked about a few minutes ago, as they develop that model, initially it's going to be tough to put together those robust models. But as we do this more and more, and develop these parametric and behavioral and activity diagrams and models, then we will get to a situation where it will become routine to provide a robust model. The key is, because the interfaces are common, then you just need specific parameters or value properties as the output of each one of those functional elements. And when you have those specific parameters or value properties as the output of those functional elements, you can feed these activity and parametric models and be able to see what happens if you put in, if you remove a module and put a different module in. You'll be able to run that parametric very quickly and digitally identify whether or not it affects the results or the capability of the weapon. So that allows for very quick trade space analysis. It allows for a very quick assessment of requirements compliance and very quick assessment of operational effectiveness. So as we get these things built, we get to the point where you can start dropping things in and actually identify your integration issues before you ever build your first prototype. And that's really the goal ultimately, is to be able to put these digital models together in such a way that, that the digital model will represent the real world, and you can test these designs digitally before you ever have to build anything. All right. So what is the status of kind of where we're at right now at Eglin, and specifically within the Armament Directorate? As I've mentioned earlier, we have the weapon open system architecture. That's already been put into a SysML digital model. So it's ready to go. The interfaces are established. The functional elements have been established, and there is a scheme for passing information between the various functional elements. And so we have those interfaces well established. Those internal interfaces are well established. I mentioned the Weapon 1 GRA. It has a lot of good work done in there. We're specifically looking at the requirements piece and looking to draw a lot of those requirements into the model. As I said, over the summer, there's a lot of external interfaces that we think we can bring in as well. That work has been done in the past on paper. There's still some work to be done to tweak those a little bit, but then we have to bring them into a digital model. So that's kind of the path, is to bring in those Weapon 1 requirements, the weapon open system architecture internal interfaces. We'll work on some external interfaces over the summer, and then we'll just continue to improve. There are some program GRAs here at Eglin. We'll be looking at those as well and seeing what we can leverage there. And all this will ultimately result in what becomes the Weapons Digital Enterprise GRA. So let's go to the next slide, please. Sorry. And so that's kind of what this next slide shows, is pulling capability from the Weapon 1 GRA, as well as the weapon open system architecture, and then implementing GRAs around Eglin, and pulling all that into what becomes the Weapons Digital Enterprise GRA. Now, once that gets pulled together, like I said, this summer, we'll pull a lot of that together. We'll continue to develop for the next year or so. There'll be a lot of iterations and a lot of maturing that will happen very rapidly. Once this GRA gets to the point where it's somewhat mature, it will not stop changing. It will be a continuous evolutionary process. We know that technology will change. We know that threats will change, and we'll need to continue to update this government reference architecture. And our ultimate goal is to get to the point where the digital testing is infinitely close to actual flight testing with respect to verification of developmental and operational requirements. So like one of our home improvement stores says, never stop improving. And so that's would be our intent with the government reference architecture, to continue to iterate, to continue to improve, and to continue working on those parametric, behavioral, and activity diagrams and models to improve this GRA to the point that it represents, it digitally represents the real world. Thank you.
All right, thank you so much, Mr. Ammons. And we are actually going to take a quick intermission. So if you need a chance to get up from your computer, grab yourself some more coffee or breakfast if you're on the West Coast. It is currently 11:09 Central here where we are, so we are going to take about 5 minutes and we will start broadcasting with our next speaker promptly at 11:15. So that's in about 6 minutes. So we'll be back with you shortly. Okay, welcome back from our quick break. Next up, we are going to have a brief on Weapons Open System Architecture, or WOSA, by Mr. Jonathan Shaver from the Air Force Research Laboratory Munitions Directorate.
Thank you. Also on the screen, you can see that Chris Neal is on there. He's basically my counterpart, and we're brave enough to put our email addresses on these slides. So please, if you have any questions, interact with us. We want industry and government to collaborate together as much as possible. Please reach out to us on any questions that you might have. Next slide. So Weapons Open Systems Architecture, what is that? It's basically, a non-proprietary architectural standard for munitions. However, it's basically we've broken up a weapon into various functions and components. We've standardized the interfaces. And if you look on the right side of that slide there, you'll see an abstract representation of WOSA. That's one configuration that you could put together. Unfortunately, a lot of times when you put together examples, people think the examples is the answer. And that's not necessarily true in this case, but it's the easy way for me to represent our architecture on a screen. And so all of those orange arrows that you see back and forth there, we have taken and we've standardized those interfaces, at least from a logical perspective at this point. Also, that munitions data bus, connecting everything together, we've written specific rules to basically how you would go about implementing that inside the weapon system. And so one of the big things that I emphasized before is that this was developed and maintained with industry consensus. We think that's a really big deal. We hold working groups every quarter. We've been around a long time. It says 7 years of maturation. That is true. So we're more than willing to work with the industry. We don't want to necessarily preclude anybody with our architecture. So if we make a decision that might, hamper your company's implementation, we want to hear that out. We want to try to make those changes to where everybody can play in this game and move forward. And we do those through these working groups. We hold quarterly working groups, once a quarter. And I guess for the last probably year, we've been holding them virtually. Not normally the best way to do it. Typically, we've had those in person at Doolittle Institute, right here where we are today. And this is an investment. AFRL put an investment into this 7 years ago. It's a $40 million investment. We're very happy with the products that we currently have. And what those products are this government-owned reference architecture. We have a requirements verification specification. We have a Munitions Open Architecture Test and Evaluation Lab, MOTEL. And our MOTEL team is basically the one that handles all of these 3 pillars of success that we have here: maintenance, expertise, and validation. So when you show up to a working group meeting, it will be the MOTEL team that will present the maintenance piece of that. So when we get comments in or suggestions in, we basically go to the lab, go to that MOTEL team, we run some analysis on that, and then we present that to the group. So we're making decisions based on data. We're not making decisions based on our gut feeling or a company wants to do it this way versus the way everybody else agrees to. We can point to a piece of data that says, this is how we're going to do it. Next slide. So since we've been around for basically 7 years now, what I wanted to do is I wanted to go through each one of those pillars: maintenance, expertise, and validation. And I wanted to kind of give an update of where we are in terms of WOSA and what we're doing moving forward. As Mr. Ammons mentioned before, he mentioned this reference architecture definition. I've included it up there. So we were officially listed in the Air Force Digital Transformation GRA catalog in September 2020 as a GRA for weapons. In September 2020, we also released the version 2.0 of the architecture. We had an ICWIG, which is an interface control working group. We had that in September as well to talk about the changes that we put into version 2.0. And then most recently, you've seen that we released this WOSA GRA, which is basically a SysML model of the WOSA architecture. And we put that out on our APAN group. You can see the 2 links there in the slides. You can access APAN. Once you access it, you just request from us whether or not for access, and we will approve that access. You can send us an email to do that, or you can go directly to this site and type in the WOSA group, and it will basically do that for you. From our WOSA perspective, inside the bounds of a weapon, WOSA is the authoritative source of information based on the definition that we have there in terms of the reference architecture. And then we have working group meeting 12, which is government industry feedback. And that's on April 8th. So we announced that, I think, about a month ago, probably right before we released the WOSA GRA. So we're looking for feedback from industry on that GRA SysML model, as well as some of the other changes that we've put out there. One of the big things that we've added to the WOSA architecture is this metadata updates. This will include static and tunable domain parameters. So this is basically filling out those pieces with respect to WOSA that won't fit in messages. So they won't fit in messages because they're typically not in messages. This is domain information that's typically hidden in either metadata or something like that. And this tunable and static domain parameters will enable things like, I hate to use the word plug and play, but it will bring us at least closer to a plug and play type system. And that's the big draw for that. So we've taken the metadata section that we have and we've basically stretched that out into these static and tunable domain parameters. We've also done some diagram updates, and then I'm going to step through some other areas that we've updated and that we can have those conversations on April 8th, where we get into the architecture and the changes that we've made in terms of analysis and other things. Next slide. So this is one of those things where we talked about expertise. So when the government is doing or requiring a specific architecture, the government needs to be smart enough to know that this architecture is able to be implemented on various systems that it includes. And one of those things that we did extensive work early on about air-to-ground capability and what the air-to-ground problem would look like. One of the things we didn't look at were hypersonic airframes, and we're beginning to look at those now. Our next step from air to ground, we started focusing on air to air. We presented quite a bit of information at the last working group. And during the last working group, one of those questions that we posed, and I'd like to pose it to the folks listening now, is we were getting into the point where we were going to start looking at trajectory shaping and GIF analysis. Now, we did some guided integrated fusing analysis previously, and I would encourage you to go on that APAN site and look at the work we've already done in terms of the guided integrated fusing that we've done. But if we start utilizing this new guidance shaping law, it's obviously going to correlate with the guided integrated fusing that we're working on now. And what I'm hoping that you will do is you will take this back to your engineers that know exactly what this is. These are ProNav equations with some modifications to them, and they should know what this is. And if you could ask them for input, we've still got 2 weeks away from April 8th where we can change some of this analysis that we're doing, but we're doing this analysis, and we typically give this analysis to the community for free because we think it's important, and the government needs to build their tool base to be able to understand open architecture. And so if we're going to start requiring these things, the government needs to be just as knowledgeable about what they're requiring as various prime contractors are. And this is a major piece of that whole thing. So, basically, if you can, the idea here is if you can take this back and provide inputs, are we doing this appropriately? We're welcome to change it. We presented to the last working group and we got no real pushback from it. Typically, I take silence as acceptance. And so we've moved forward with this in terms of the direction we're going to go for our future analysis. Next slide. So on this last slide, it's basically, this is another piece that Motel provides to program offices. It's basically contract validation. So when we put requirements in a contract, we need to make sure that the items that we received were upheld. So if we ask for specific information, so an implementation GRA, for example, a lot of times we'll look at that information and we'll just look at it and go, well, I guess this looks right. I mean, I suppose this is correct. But what we're really looking for is whether or not we've got all of the information capable to hand that GRA to another person and to another company that might not have had the familiarity with that GRA to start with. And how do you validate that you've gotten all the correct information without actually working on it and using it or validating it to a piece of equipment? And that's exactly what we've built up here. So we've built up a segment of tools to where we can validate contract requirements against hardware. Internally, we just, it might be a process where we do software configuration and other things like that. So we do some level of implementation to ensure that we've gotten all of the information we need to hand that to a third party. Because typically if you just have SME inputs looking at that, there's extra knowledge there that's typically not known. And we've done this for a long time. We've done this for 7 years, and we've gotten multiple systems in, and not one of them has been perfect when we've got it in. So not one of those would have been perfect for us to hand it to another contractor for them to work on. So that's exactly what this WOSA tools and validations is set up for. And so one of the things that we updated is this ASOT software and analytical tools for system architectural trades. We're doing basically all the work that I showed you before. We typically do in MATLAB, and then we write it in C, turn it into a tool, and then we put it into the ASOT going forward. And that's exactly what we've done. We're starting to do now. We've also captured a lot of early acquisition strategy development, so we can get a wag at what various implementation architectures would be based on. And the acquisition community can make decisions based off data and not off gut feelings or what could have been, off real scientific data that we've developed in this these tools and validations. And this OATS, this Open Architecture Test and Emulation System, this is to verify the newly implemented variable and static domain parameters. This is one of those things, obviously when you add something this big to the standard, you've got to come up with some way to validate what I'm asking. So when I write a new requirement in a contract, I always need something to validate that requirement. What am I going to do with that? And that's exactly what this tool is. And you'll see more about this in April when we hold our working group. And then of course, we're doing some Motel verification software, minor updates to the code base. Most of that Motel software is available on that APAN site. So all of these tools we give to industry. So before you show up to our door with a product, you should know the answer that we're going to give you back. And so that's our model that we've stayed with. Another thing we did, Gray Wolf WOSA validation last month. Actually, it was in February. That went well. Again, this goes back to what I said in terms of nothing's perfect when it comes in, and we're going to discuss that in detail. But overall, the Gray Wolf validation testing went well, so don't take anything from that comment. It's just, I'm trying to stress the importance of us doing contract verifications in the future. And that is basically all I have for this. So thank you.
All right, thank you, Mr. Shaver. He was from AFRL RW. And if any of you did not catch his email on that first slide during his presentation, we can send it to you in the chat so that you have that. He offered to have you email him if you had any questions for him. So I'm going to do just a quick intermission again so we can get our next speaker set up and ready to go. So it's currently 11:30 Central Time. Going to take about 5 minutes. So we'll come back on at 11:35 Central and see you back in 5. All right, welcome back, everyone. Next up, we have Mr. Timothy McIlhenny. He is with the Air Force Lifecycle Management Center, EB, which is the Armament Directorate on Eglin. And he will be talking to you about some DASO vision. DASO, again, if you have the agenda, you'll see that's the Digital Acquisition and Sustainment Office that is under AFLCMC EB. All right, so Mr. McIlhenny.
Good morning. As she just said, my name is Tim McIlhenny. I go by Tabasco, that's my call sign. I'm the cybersecurity lead at the Digital Acquisition Sustainment Office. I've been on board now about 3.5 months. And I'm here today to talk to you about what we are doing in the SAP environment to create that collaborative environment that is crucial to implement, the vision of what is being talked about today. I want to recognize that I'm up here speaking, but I represent a larger team. And that team, that cuts across the EB, that team is primarily made up of folks out of our operations branch, EBO, both the cybersecurity and the IA side or IT side. They're the ones that will do, the hard work to implement what I'm going to talk about in the next 10 minutes. Next slide. Okay, I took this from a vision slide that Colonel Hoffman had put together for DASO. It came out of a briefing, what is DASO? Talking about our vision for creating this collaborative environment. So the current status, as you know, if you work in this environment, we have multiple independent enclaves. They don't really talk to each other. We don't talk well to industry. The connections are low bandwidth. We can't really move large data files around. And it's totally an unsatisfactory environment to do what we need to do to implement digital engineering and digital acquisition. So we have a three-pronged approach that we're taking to solve this problem. So the first is to create this secure environment where we can collaborate. When this slide was first put together back in January, our way ahead was not clear necessarily, but we've since coalesced to we're going to move to the cloud. That is the best way to do this. I'll talk more about that in just a second. The next problem we have is, again, as I said, we don't have a good way to move big data around. So we've had to use draconian measures to do that in the past. That is a problem we definitely need to solve. I'll talk about more, our way ahead there in a minute. And the other piece, just as important as the cloud implementation, is the connections. So the government, have to be able to connect to this cloud solution. So does industry. So that will take potentially some internal investment by industry to make this happen. And I'll talk more about that too. Next slide. Okay, so how are we going to implement this cloud solution? Well, the answer is Fences. So Fences is a SAP compliant cloud. It's been accredited by the DoD SAP CIO. What we call S-Fences, the secret SAR fences, that piece has recently been accredited. That is where we will first move to. Fences itself is an overall PL3 environment. They do have some, software as a service capabilities, but to meet our EB requirements, we are going to have to build our own EB, so to speak, PL3 environment in Fences. For a number of reasons, but one of them being that will enable us to communicate better with industry because our networks are not necessarily always compatible. But this is where we're going to create that collaborative environment to do model-based system engineering, digital acquisition. One thing I do want to mention is we will also down the road set up an unclassified, we'll basically mirror our secret SAR piece in the unclassified Fences cloud, because I think that opens up opportunities for you, industry, to do more work in the unclassified environment using like your SysML tools, for example. You can do a piece of a design, and then that can be pushed up into the classified environment. I think this will help us go faster. And again, I think, it's really a good opportunity there. But fences is the only solution right now out there. It's managed by a company called Novetta, and we're working very closely as we begin to implement our cloud solution. Next slide. Okay, just as important as the cloud environment is the connections to that environment. So if you look at the slide, we'll start in the upper left-hand corner. Summit. Summit is a new enterprise network that is being rolled out by H&J out of Hanscom. They are currently finishing up some of the beta testing at a couple of sites. They will be rolling out Summit to the first, operational, so to speak, customer. Thanks to Colonel Hoffman, we have been moved up to be the number 2 entity to receive Summit. So we expect to get some Summit capability here at Eglin, possibly October timeframe of this year. But, Summit is an approved connection to fences. It's going to give us, I think, greater bandwidth and hopefully more flexibility than we currently have with our enterprise networks. The middle piece is ICON. That is an industry gateway into fences. I don't know a lot about ICON at this point in time, but I do know people who do. And if you have questions, I can point you to the right direction. I do also want to add that Summit, according to H&J, can also be used by industry to connect. But in the meantime, we're going to have to use our low bandwidth existing enterprise networks. But one, I think, early victory we had, and I want to give credit to, our chief engineer, Greg Thomas, for making this happen, is we have been able to get DRAN added as a required connection to fences. It's going to be about a year, maybe a little bit longer before there's a DRAN point of presence in place that can service fences, that, it gets through the accreditation and approval process. But that's where I see us beginning to be able to move these large data files around. So I'm really excited about that. So next slide. So in summary, we have a target program that we are actively in the beginning phases of working to move on fences. This will be a PL3 environment that will be the archetype for the other EB programs. And, we're going to learn a lot from that implementation. As far as how are we going to phase in, the rest of our portfolio, the Tabasco opinion is that, some of the newer programs will be the next to come on board, and then some of the legacy programs will move in as it makes sense over time. One thing I do want to touch on real quick is that we are working some kind of midterm issues to have better connections to fences. So we're trying to get a team from H&I down here that will check the capacity of our existing enterprise network to see if there's any bottlenecks that we could potentially open up. And we have the potential opportunity to leverage some work EBO has done to potentially get a hybrid, direct connect in the fences while we, work these other longer term connection capabilities. But in summary, we see the cloud as the future for this collaborative environment that we need. We're actively putting a lot of effort into getting there. And we also are putting a lot of energy and eventually money into the network piece. So industry, I would encourage you to do the same. Of course, some of course would be paid for with program dollars, but I do believe there will be internal funding that will be required to reconfigure your networks to support this cloud environment. So I appreciate your time in listening to me today, and I will yield the floor to my distinguished colleague from AFRL, Scott Dawes.
Hey, Laura, would you put my email in the chat session? Okay. All right, we'll get this blown up here. We'll get started. Ready? All right. Hello, everyone. I'm Scott Doss, and I'm the RogueONE RogueONE Software Factory Program Manager. I'm also the lead engineer for the Cyber Assured Munitions team. That said, today you may be asking me, Scott, what is the RogueONE Software Factory? Well, I'm going to tell you what it is. The RogueONE Software Factory is basically the interstate towards Dr. Roper's vision of the digital trinity. And when I say digital trinity, I mean the agile software development, the modular open systems, and the digital engineering. That's how we're going to get there via the RogueONE Software Factory. Now, exactly how, Scott? That's what you're thinking. Well, from the agile software development side and the open modular system side, basically what we're going to do is implement Nick Shalon's, the Air Force Chief Software Officer's vision of the DevSecOps reference architecture. Now, the DevSecOps reference architecture goes out and tells you exactly how to stand up a software factory, from using GitOps, infrastructure as code, configuration as code, how to manage that, and look at the different microservices, all based on Kubernetes. With that in mind, we're implementing that to cover the first two, the agile and the modular open systems. Now, for that third leg in the Trinity, for that digital engineering, we're going to implement the model-based systems engineering as well as the MS&A tools within the cloud. That's the approach that we're taking at this time. Now, when I took over this position about 10 months ago and Dr. Sumpter went out and said, Scott, go make this happen. I want you to take over the RogueONE Software Factory. And we're going to do digital engineering. We had to come up and figure out the approach that we were going to do. If you look at the slide there, first we had to go out and say, all right, where are we going to host this? So we're going to have a hybrid multi-cloud that's going to be hosted in Cloud One, some on-prem, Amazon AWS fences, as well as Secret Vision, S-Vision. That's the development network that AFRL uses. So we had this identified, and then we began to acquire those services. Next, looking up the stack, you're going to see the platform side. Well, exactly how are we going to do this? Well, with the reference architecture that they've put together, Platform One is actually developed. And Platform One offers several services, from Party Bus to hosting things and hosting their pipeline, to actually going out and taking their Big Bang engineering and onboarding courses. So with them teaching people and offering this infrastructure and code as a service in these repositories like Iron Bank or Repo One, we sent engineers to the C++ embedded systems courses, as well as the Big Bang courses. I myself attended the Big Bang course where I learned a lot. What GitOps really means to the Big Bang and the Platform One team. The infrastructure as code, the suite of technologies that actually make up that Big Bang instance. And one of the things that I think is crucial in moving forward is that we learned from the Big Bang team that if you implement their configuration of the Big Bang, that it's supposed to meet 90% of the RMF controls. Yeah. I know you say 90%. We'll see as we begin to implement that. We actually, within RogueONE, we have our own ISSO that we've appointed, and we'll be working with programs and their ISSMs, their SCAs, and their AOs as we stand up these CI/CD pipelines to ultimately achieve that continuous authority to operate for those individuals. Now, within that Big Bang and the DevSecOps pipeline, we've actually are going to be standing that up in our IL Level 5 Cloud One instance, as well as our S-Vision and the fences side of the house. To date, we've already stood up a Cloud One Dev Atlassian stack that basically made up of Jira, Confluence, Crowd, Artifactory, X-Ray, and SonarQube, just to mention a couple of tools. That's up and running at this date, and if programs need access to that, we can give them access to that to actually allow them to go out and test and learn how to do the Jira, how to learn how to utilize Confluence and the wikis and the retrospectives. Now, this is within the dev environment, so we can't put CUI information in it at this time, but it is a dev area where if you have some unclassified, non-CUI related stuff and you would like for your program to actually learn, we're offering those services to programs within AFRL, LCMC EB, as well as the 96 Test Wing at this time. We have most recently acquired our IL5 access to have a integration VPC, a test VPC, as well as a production VPC. We're standing that up right now. Our goal before the end of the summer is to have the Atlassian containerized and Big Bang containerized stacks running at the IL level 5 by the end of the summer with users utilizing that. We're actively encouraging programs to onboard with the dev side so that we can basically pay that technical debt and the learning curve with the programs up front, maybe before we get to the IL5. You see, I have the dev environment, and then I have engineers working in the IL5 environment right now. So if I can train the users on the dev side of the house now, when we stand this up, that transition, the migration of the data and the transition of the tools, the skill sets will already be there so that we can become operational quicker. Another thing that we're doing within RogueONE is we're looking at the training aspect. We've got some training license that we can rotate on a subset of people so that we can go out and define these training workflows. For example, Agile, Jira, Confluence, things like that, so that the programs will actually know and have the skill sets to utilize these pipelines as we move forward. Next, moving up the stack, you have the integration layer. The integration layer, this meets that third principle of Dr. Roper's Trinity. That's going to be the integration side, the digital engineering, that MBS&E, MS&A tools. So what we're doing for that is we're standing up the Magic Draw Cameo Enterprise Architecture, Teamwork Cloud, and Teamwork Collaborator within the Cloud One IL5 environment, as well as Fences and S-Vision. Now, moving forward, we realize a lot of people hadn't done this and achieved this yet at this time. There's several organizations out there that have, but there's a lot of technical debt that we have to pay up front. So we're continuously learning how to do this and the go-arounds. We're working with other areas like Platform One, Cloud One, and various programs that have done this to try to solve some technical debt. Most recently, you know, we realized we need to implement the VDI within Cloud One. So we're going to go out and we're going to stand up VDI associated with these so that your programmers and your developers and modelers can reach into the cloud there, bring up a client, and model everything within the cloud. This is going to be a huge win and facilitate the development and modeling tremendously, because there's times that you may not be able to run a specific software on the NIP or net, or the ISSM says, no, I'm not going to allow that. So by having everything here and it's approved, it's going to facilitate that MBS&E, which is the third of the Trinity. Moving up, we have the program management side. With program management, we're talking collaboration and agile, open, and modular. And that's what we're doing with our Atlassian stack, using the Jira and the Confluence, working with programs, giving them the tools to do that. We're also working with the DASO, Colonel Hoffman's group, as well as Tabasco, the previous briefer, on looking at the capabilities and defining the transition of capability and who's going to be doing what moving forward. Most recently, I've been working with their POC on training Agile. We've stood up some stuff within the RogueONE area on the Confluence page that has recommended best practices. We worked with PEOBES and pulled some of the information they have and added our own to basically go out and get this capability to the field faster. With that said, I'm going to leave you on this note. We're trying to implement Dr. Roper's vision of the digital trinity with agile software development and modular open systems. And we're going to be doing that by the Chief Software Officer's DevSecOps reference architecture model, all within the hybrid multi-cloud, some on-prem, some within the cloud. We're also going to touch that third leg of the MBSE and MS&A side. We're going to tie that to the digital engineering, with the goal here to provide that information highway towards achieving Dr. Roper's and General Bunch's vision of digital engineering. That's all that I have. With that said, I'll turn it over to Dr. Sumpter, the Weapon One program manager, and just outstanding guy. While she's bringing Dr. Sumpter's slides up, I see we have one question. Will RogueONE be compatible with fences as Cloud One? Well, RogueONE is the overall program and it's the concept with a subset of the DevSecOps processes and pipelines. So we actually have worked with SAF CIO and we have an instance of fences at this time, and we're working to bring that up and install our Big Bang cluster within that. So will it be compatible? Really, it's not a matter of compatibility, but it's a matter of the tool set we're putting in fences. So hopefully that answers your question. Dr. Sumpter?
Thank you, Scott. All right, so next up we have Dr. James Sumpter. He is with the Air Force Research Laboratory Munitions Directorate, or AFRL RW, and he is going to be talking now about authoritative source of truth, or ASOT. And you'll also get to hear some more from him later this afternoon after the lunch break about the weapon digital twin and Gray Wolf. So Dr. Sumpter has a very large role to play here in the digital engineering enterprise on Eglin and with the lab. So with that, I will introduce Dr. Sumpter, and after this brief, we have our lunch break coming up.
Thanks, Laura, for the introduction. Well, it's a pleasure to be here with you today to talk about the authoritative source of truth as one of the key tenets of the Digital Agile Open ecosystem and weapons digital enterprise that we're working with our partners across the base to enable as the capability of the Air Force to deliver weapons faster to the warfighter. Can you do the next slide? So what better way to begin a conversation about the authoritative source of truth than with some authoritative sources? I'd like to point back to the OUSD R&E's office publication of 2018, the Digital Engineering Strategy, where their tenet 2 of their goals and focus for part of our digital engineering strategy and vision across the DoD is to provide an enduring authoritative source of truth. One key word that I'd like to point out within this paragraph that's up there is consistent information for use over the life cycle. We'll be coming back to that principle shortly. Then, of course, many of you hopefully have read There Is No Spoon and the follow-on Bend the Spoon by Dr. Roper, who has done a great job and will be somewhat missed from his office with the Air Force for his flair and his communication skills and capabilities and messaging some of these difficult topics. But he's published a couple of things fairly recently here that talks about this, that also mentions, in this case, a single source of authoritative truth. And the key word here I'd like to point out as one of the enabling aspects of this that we're looking forward to is automation and what we do. So I'm going to go through kind of weaving throughout as talking about these different topics, 3 different aspects of the authoritative source of truth. First, defining what it is and how we're going to go after it, and then recognizing that this is something that will have to, of course, be governed and how we're going to use this. It may seem a little bit strange to be talking about authoritative source of truth. And that word truth often, I think, at least for me, makes me think of like bedrock and solidity, stagnant maybe, if you will, or static. And nothing could be really further from the truth as we're talking about what the ASOT, as we call it, the ASOT, we envision enabling for us. And I like to put some analogies to this, just like you think about a sprinter whose objective is to go as fast as possible, as quickly as they can get there and accelerate, starts off from a firm foundation in the blocks. Or a martial artist that's going to go into combat will set his stance firmly. Or whether you're Neo and you're dodging bullets, or you're Trinity displaying some impressive, flexible, evasive, defensive maneuvers, all of these things start from a firm foundation. And we think the data and the models that we collect in the authoritative source of truth are going to give us that capability for the future. Next slide, please. This is also out of the digital engineering strategy, and I like to talk about a couple of things here. One, if it's not right out and obvious, is that life cycle aspect that I talked about. And the other thing is, if you look along the left-hand column, kind of a y-axis there, the list of stakeholders. This shows you a couple of different axes across which the authoritative source of truth is very important to the program. And it just represents a few of the axes, though, across which the authoritative truth has to span. Mention the stakeholders. That can represent people, but it can also represent different domains and disciplines across the life cycle that we're concerned with. Another thing, if you'll notice the connectors that move up and down with the life cycle representation and that pipeline showing the authoritative source of truth flowing across the life cycle, is that there are dots at both ends. And this is to represent the fact that data is envisioned to originate in some of these places across the life cycle. And it's also going to leverage data that maybe has come before, is already residing in the authoritative source of truth from other programs. And so this is another important aspect to this that I want to make or point out, and that is we shouldn't look at the authoritative source of truth in a siloed or program-specific application. We need to architect and design our authoritative source of truth so we can leverage what's in common and what can be reused across programs. So we want to look at it from the standpoint of functionality, of capabilities, classes of capabilities, and so forth, as we establish the higher levels of this authoritative source of truth. Next chart, please. This is another very simple diagram, and all I want everyone to take from this is how we position the authoritative source of truth, kind of in the middle of this overall view. If you consider what you've heard about earlier this morning about the weapon government reference architecture, and if you look at that in terms of being a high-level framework that is somewhat empty as it comes out, it's a template against which we broadcast to you our requirements, and we expect our industry partners and developmental partners, whether it's from the lab or others, in developing these concepts up, to use that template so that we drive some standardization between the models that we're going to use ultimately to hold the data for our authoritative source of truth. Those weapon GRAs can be applied specifically to a system of interest. It can be a component or subsystem, a whole system, or even a system of systems in an ABMS JADC2 type paradigm. And that's where we have at the bottom the weapon digital twin thread. That's the DTT down at the bottom there. And this is where you might collect serial numbered type specific information within a government reference architecture applied to a specific weapon system and collect that data. As you aggregate that data, though, and bring it together across the entire class of that specific weapon system or class of weapon systems or capabilities, and you store all of that, you start to build up that authoritative source of truth across your weapons digital enterprise. So it's a combination of a top-down and a bottom-up approach. Next slide, please. So I've mentioned bringing this data in across different axes. This is another way that I like to look at this from a publication from Dr. Kraft. If you're curious about more of this subject, I encourage you to read some of his papers. But we have a diagram there. You'll see variations on this as a variation of this diagram in that digital engineering strategy I mentioned earlier. But your takeaway from this is that this is really meant to be incorporating the bidirectional flow of data from all of these different aspects across domains and disciplines across the life cycle of the weapon systems. And we want to collect those things together as an authoritative source of truth. One of the things I haven't pointed out yet, and if you've been around a while, and there are still people that talk about the authoritative source of truth as a single source of truth. And we've taken the word single out from this, recognizing that because of it being cast across and collecting data across all of these different disciplines across the life cycle, that it's not going to be a single source. There are different authoritative sources for this data, and hence we've changed that word out. So even though we represent it oftentimes in a single area, like in the center of this picture, we recognize that this data is going to be distributed and stored across many different people's processes, domains, disciplines, and physically stored in different places. And we'll talk about that in a minute. So going back to my earlier premise of talking about defining, governing, and using the authoritative source of truth, this is an area where there's a tremendous amount of opportunity to work with our partners in industry and academia and across the services. And of course, within Team Eglin, there's a lot of work here still to be done. But we don't have to be afraid, as General Collins said, of taking this waterfall approach where we have to plan out what does the authoritative source of truth look like in 10 years. There's no way we could design that, or even 5 years, or maybe even 2 years from now. But we do have a very clear vision that we want to get to this authoritative source of truth so that everyone across the weapons digital enterprise can benefit from it, and we can get those weapons and S&T to the warfighter faster. But there's a lot of work here left to be done in terms of defining exactly what this means, defining the different kinds of data that we need to use, the different kinds of models that we want to employ, how those things apply to the way our current DoD 5000 acquisition processes are right now. But where a lot of the change is going to come in is recognizing that when we start to collect these models and data, we start to connect this ecosystem together, we're going to enable an entire slew of opportunities and benefits that perhaps we can't actually even envision right now. And so we need to be flexible and adaptable enough to recognize that this is going to be a changing landscape. And that's the reason why we need to base all of this, as Scott was talking about, and others, on this tech stack that includes this hybrid multi-cloud environment. Underlying the sharing and connectedness of all of this data will be an architecture that involves everything from on-premise all the way up across the cloud, out to the edge, and all happening at multiple levels of security. So anyone familiar with this space can recognize that there are some huge challenges and some big opportunities there to help us solve this problem fully. But we're going after it in an agile way, iteratively, as we start to collect data, as we start to build up our digital twins, which we'll talk a little bit more about later on today. We're simultaneously experimenting with the best way to architect and to share, to collect this data in an authoritative source of truth across all of these different systems. So define, govern, and use. We need to define it for our stakeholders across all the diverse organizations and distributed locations in which they work. We need to govern it in the sense that we need to make sure that the data that we are serving is authoritative, and that often means that the best place for it to reside is with the author of that information, the primary source of the information. And this could be a new paradigm where there's data residing with our industry partners. And we need to figure out how we segregate that data and share back to the government seamlessly what we need to operate, support, sustain these weapon systems over time. And so that leads me kind of to the last bullet down there of a contract requirement. These are things that we still need to define. We've got to draw out exactly what kinds of data needs we're going to have. Many of these, I think, are yet to be determined, but expect this. This is something that we're going after, and will be a requirement in contracts of the future, that new types of data, new models and so forth, it will be expected to be available to the government for continuous review and leveraging it, especially as we get out into an operational scenario where we want to leverage an authoritative source of truth to make decisions for the warfighter there. Next chart, please. So I'm just going to sum everything up right here that we've kind of already been talking about. We've talked about it's very important that the authoritative source of truth be trusted. This harkens back to not only the primary source of the data, but this is where our partners for the test wing, for instance, can help us. They are the source of a lot of trusted data from live tests, and they can also help us develop methodologies to VBNA these sources of truth and to believe and have trust into our models and the data that we're storing and sharing out this way. It's going to be federated. It's not going to be stored in a single place. It's going to be distributed across multiple systems. It's going to be across hybrid multi-cloud environments, and there will be cases, of course, where it may be locked away on an enclave and so forth. And we have to make decisions about making this data as accessible as possible to the right people at the right time when they need it. And so we've got a lot of challenges to overcome to do that and to enable this fully digital, agile, open ecosystem of the future. This authoritative source of truth, if it weren't already apparent, of course, becomes the enduring digital thread through the life cycle of the weapons system. That continuous, unbroken thread of data that's traceable back to its source. So we have provenance and pedigree surrounding all of this data that's been laid out in a government reference architecture that we want to capture as the weapon system progresses through its acquisition process. We're going to be investigating with new ways to share or to store models, data, and code as more defined or more effects and capabilities are software defined in the future. We want to continue just like we have with Agile and DevSecOps as they were pioneered and developed in the software development industry. We want to try to take some more of those lessons learned and apply them to managing our models and data with the authoritative source of truth. And of course, this data wouldn't be very much worth to us if we didn't investigate some very smart search and retrieval mechanisms. So we want to leverage AI and ML, harken back to things like NLP to bring in traditional documented sources of data and so forth, and put those into a machine readable format so that we can get to what Dr. Roper talked to in terms of some of that automation. What we want to do is keep humans in the loop, but we want to leverage what humans do best and leverage what machines do best. And so that's where a lot of those automation of processes comes in. And the underlying premise to having all of this data is to support data-driven analysis and decisions, whether that's making investment decisions in the lab in terms of the next new S&T concept to make an investment into with the hopes of transitioning and getting that to the warfighter, or whether it's data that's used and analyzed to in an operational sense, in a mission scenario, or in order to make some command and control decisions for a commander in terms of what's the next strategic or tactical move to use. We envision the authoritative source of truth supporting from concept all the way out to the disposal across the weapons enterprise. I believe that's my last chart for this topic. So thank you. I saw a question up there. I guess I've got 30 seconds. Oh, wait, no, that's the wrong question. I was reading the last one on the list. I saw one pop up, but I don't see it there now. I was going to address it. So thank you, and see you after lunch.
All right, thank you, Dr. Sumpter. Wow, we actually made it to the lunch break ahead of schedule. So I guess all of the briefers must have taken it to heart when I told them that I would not give them a lunch break if they went over on their briefs this morning. So thank you for tuning in with us. If you're just popping into the webinar, we just finished up the 1205 brief, The Authoritative Source of Truth, or ASOT, by Dr. James Sumpter. We are starting our lunch break right now. I know on your agenda it says 12:20. It's 12:15 currently Central Time. We're going to start the lunch break a little bit early. So go ahead and do that. And we'll be back here promptly at 13:30 or 1:30 p.m. Central Time.